Alright, in the previous lesson, we have actually seen what is the use of a discriminant and how it can be used to determine the nature of roots. So some of you may be wondering, so what are some of the kinds of questions or the types of questions that can be asked? Alright, so basically I could actually break it down to maybe about 3 types. So the first one would be finding an unknown value or a range of values. Now why is it that there is a difference? Alright, so unknown value usually will come in when there are real and equal roots. So you have a specific value that you find, or it could have been a case of your positive discriminant or negative discriminant. Therefore, you have an inequality sign, right? So that thus it becomes a range of values instead, all right, because of the inequalities. And when they are asking you to find an unknown value or a range of values, they will give you the nature of the roots, all right? So they will tell you at the beginning, you use that and you continue to find, all right? So they will give you the nature. We will see this in a short while. Now the second type is showing that the roots of a certain nature. So they are asking you to show. So you do not use what you are supposed to show at the very beginning. So you use the general discriminant form instead. Alright. So you do not start with d greater than 0 or whatever, but you are supposed to show why it is indeed positive or negative or equals to 0 and so forth. And the third type of question that you could possibly have is to also find the number of intersections, if any, between a curve and a line, so, a little similar to what we did earlier on. Alright? So let's have a look at the very first one, finding an unknown value or range of values. Okay, so the question says that find the range of values of k for which the equation 3x squared equals to kx minus 12 has real and distinct roots. So you will notice that they have told you at the very beginning, okay, real and distinct roots. So this is where you have to understand that they have already told you that you have a positive discriminant. Alright, so what you are going to do is that you're going to use this to start off the question, but you realize that this is not really in the proper form. Sorry, so you have to try to make it equals to 0 on the right hand side. So I'm going to have 3x squared minus kx plus 12 equals to 0. And this will give me a equals to 3, b equals to negative k, and c equals to 12. Now since I've been already told that they have real and distinct roots, so I have a positive discriminant here. So b squared minus 4ac is supposed to be positive. I know this, right, because it's real and distinct. Okay, so you may want to write here just to keep you keep this in mind. So I have my b value, which is negative k, and I have my a, which is 3, and my c, which is 12. Alright, so this gives me k squared minus 144 is greater than 0. Now please be very careful, don't solve this the normal way, because this is a quadratic inequality. Alright, so what I'm going to do is that I'm going to use difference of squares. K squared minus 12 squared is equals to is greater than 0, and this give me k plus 12, k minus 12 is greater than 0. Okay, difference of squares. Or you could also use the factorization method. So from here, right, we can't just let this be greater than 0 or let this be greater than 0, because this is what we call a quadratic inequality. Alright, so in this case here, we will have to use something to help us. So we could actually go by the curve method, meaning that if I were to have a curve, because this is k squared minus 144, so if I were to have a curve, right, then this would be k, and this will be my two intersection points. Alright, so when k is k plus 12, if I set it to 0, this will give me negative 12. K minus 12, if I set it to 0, this will give me positive 12. Alright, so greater than 0 means that I want this part here that is above the k axis, so to speak. Alright, so greater than 0 means any values that are above here, and any value here, right, is to the left of negative 12. So which means that my k is less than negative 12. Or it could be actually over this side here, alright, to the right of 12. So it could be that my k value is greater than 12, and this will be my final solution. Alright, so this is the range of values. K can be either smaller than negative 12 or k can be greater than 12. And when I have these two cases for the k here, then I will be able to get real and distinct roots. Now some of you may not be very comfortable with this method, so I have another method for you. We could also go by k here, so I can have negative 12 and 12, and I will know that I will break this down into 3 possible sections. Alright, section 1, section 2, and section 3. Alright, so I'm going to find out when this is the middle section. It's always going to be alternate, alright? So like for instance, if I choose a value 0 here, so based on k squared minus 144, alright? K squared minus 144, if I choose k to be 0, I will end up with negative 144. So which means that any number that is between negative 12 and 12, alright? Any number that's between negative 12 and 12 will give me a negative number. So which means that this is what I call the negative section. So if this is a negative section, this will be the positive section, and this will be the positive section as well. It will be alternate, alright? Actually, it is related to this. See? Positive, negative, positive. Okay, so we have positive, negative, positive. So just by picking a random number in the middle section, and I thought the easiest would be 0, then I find that this is actually a negative value, so this is actually a negative section. Now, since I want it to be greater than 0, means I want the positive section, so this will give me section 1 and section 3. So section 1 numbers, right, are here, alright? They are less than negative 12. They are in this section here. So again, I have k is less than negative 12. Or it could be that they are in the third section. So third section numbers are greater than 12. So there you have it. So you would also be able to use this method in order to solve the quadratic inequality. So this will be the range of values if I want to have real and distinct roots. Meaning that if I choose k to be 13, since it's greater than 12, right? And I put it in here and I solve it, I will be able to have two solutions. But if I choose a k that is not any of this, alright? Let's just say I choose k to be 10, for instance, alright? So 10 is not greater than 12, right? And I put it in here, I will find that I actually do not have real and distinct roots. Okay, so let's look at another example. Find the range of values for which x squared minus 10x plus 4 minus m is greater than 0 for all values of x. Now you will realize that they didn't tell you explicitly what kind of roots there are. They ask you to find the range of values, alright? So remember I told you when they ask you to find a range of values or to find an unknown value, they will have to give you the nature, right? But in this case here, they did not tell you. But what we can see is that when we have this case here, right, this is something like your quadratic curve, alright? Y equals to x squared minus 10x plus 4 minus m. This is something like your quadratic equation, alright? So this is your quadratic curve. So if I say that this is greater than 0, means that I want every y value to be positive. So every y value positive means I could have it this way, alright? So assuming this is the y-axis, this is the x-axis, my curve is entirely in the positive y portion. It will not touch, it will not cut down. It is all in the positive y section. Okay, the y-axis is here. These are all the positive y values. So what does this mean? Alright, if it's always in the positive section, it means that my curve and the x-axis will not touch, will not cut. So since this is a floating graph, alright, from the earlier part where we actually did the floating graph, we realize that it will be this case where there are no real roots. So they have actually told you in a roundabout way that there are no real roots, alright, because my curve is always in the positive section. So what I can say is that for this case here, it means that I have no real roots. In other words, my discriminant would be a negative discriminant. Okay, so knowing that, what I can do is that I have A as 1, okay, B as negative 10, because that's the value outside of x, and my C is 4 minus m. And since I know that there are no real roots, b squared minus 4ac must be less than 0. Okay, no real roots. And then I will have it as negative 10 squared minus 4 times 1 times 4 minus m is less than 0. And I'll be able to have it as 84 plus 4m is less than 0. Okay, I did it quite quickly. If not, then you can actually say it this way. And 4m is less than negative 84. And m is less than negative 21. I do not change the sign because I'm dividing by 4, not negative 4. Alright, so in this case here, this is the range of values for my m, for which this is always positive.